C. This sort of ties in with Ryan Warner's talk about writing bindings. So I'm excited for it.
Adam's talk about optimizing that stuff.
And also Adam's talk about optimizing your machine learning. So I mean, this is really bringing it all back together. Yeah, excellent point. All right, give him a round of applause.
Hey everybody, my name is Alvaro. I'm a production engineer at Facebook and Instagram. I will talk to you about Cython, like my friends already here said. This name is awesome. I didn't come up with this name, but it's Python with a dash of C. I think I'm gonna start using it forever. I put this slide before, so you don't need to see it again. Yeah, okay, cool. So let me start with a question or two. Who here has written C extensions for Python? Okay, great, that's awesome. Everybody who didn't raise their hand, this talk is for you. Now, for the people who raise their hand, who has written extensions in Cython? Great. You guys are gonna be bored out of your mind. This is supposed to be so every talk is somebody first talk about something. So this is me trying to introduce to you. I went through the process of creating the extensions, and I want to tell you the best tool to do it. But before we start, let me try to discourage you from writing C extensions. So here's the big question: why would you write a C extension? Anybody has any idea? Go ahead.
So as you know, you should never process HTML using regular expressions.
Yeah.
Friends don't let friends do that, right?
Yes.
Every search engine does that, and it's not fast enough, and so then you're like, damn it, I want a boy or more expression matcher for these 5 characters, and then I want to go this direction for up to 100 bytes, and that direction for up to 100 bytes, blah, blah, blah. And then when you're done, you're like, wow, this is 10 times faster. But I'll tell you, the funny part is, you said I would be bored by this talk, but I'm not, because what I did was I looked at somebody else's Cython thing and somebody else's, and like, my Cython code is total cargo cult. And I screwed with it until it worked. And then I left it, and it's probably wrong, but it works.
Yeah.
So I don't know what I'm doing, because I don't understand the philosophy very well.
The funny thing about that, is that HTML is not regular, so you should never use regular expression for it. It's right there in the name. Come on, guys. Okay. So at least in my experience, there are 2 reasons why you would create a C extension. The first one is that you have C code that exists and you want to interact with it. That's at least that's the main reason, and that was how I got introduced into this. So there are like really cool things out there. Like there are this new RocksDB that if you want to replace your SQLite, you can use it. There are the CSTV, or basically anything under US Lib that is like a toy box for geeks. So you can just go into that directory, and it's full of SO, and you can import them, and you can play with them. So that's one reason. The other one is this one, right? Like C is faster, right? So this is another way of saying Python is slow. So this is kind of like in every survey, when everybody asks you, do you think Python is slow? They give you 3 answers. Yes, definitely, absolutely. And I don't want to debunk this myth that Python is slow, because yes, Python is slow, but I want to actually make sure that we understand what kind of slow it is. So your program usually is doing one of 3 things: is using CPU, is using memory, or is waiting on other resources that are using CPU, memory, or waiting on other resources. So this is kind of how things work. So let's imagine this code that it's stupid, but it kind of exemplify what I want to show you. So imagine I take a request, I get a web page, then I take the length of that web page, and then I multiply it by 4, and then I return a string serialization of a JSON representation of a div. Cool. Where do you think most of the time of this function is spent? Yeah. So why do we spend so much time there? It's network, right?
Light is not infinite.
Exactly. And also the server at the other end could be really busy. Do you think that rewriting this code into C will make it faster? No, because it will not make the server. Maybe we need to rewrite the server, but not this code. So now imagine that your company grows and you hit this code 42 million times a day. You're going to say, okay, this is really slow. So the first optimization that you're going to do is that you're going to change that request into a cache library where the first request is going to pay the penalty and then everything will be lightning fast. Now, where do you think the penalty is on this function? It changed, right? But this is a problem that you have once your server has scaled up. Now, probably the length is an expensive operation or the size or the serialization. But this is a penalty that you pay once you have 42 million requests. So again, as we all say, the early optimization is the root of all evil. So with that, me trying to discourage you from writing C code, let me just write C code for you. Okay, so do you guys see that okay? Or let me see. Yeah, no, I don't have any profile. So, okay, so let me explain my setup and then we can go. And the idea of this is that you can take this and go and write C extension for yourself. So here I have a Fibonacci function. Don't judge me because I write that Fibonacci function that way. And here I have a profiler code that will basically just tell me how long that function takes. So if I run it, it will tell me, hey, it took about 1.5 seconds to run it. Okay, cool. So if nobody knows what Cython is, what I'm gonna do is I'm gonna take that file that I have there and I'm just gonna copy exactly like that. And I created basically a file that has exactly the same context but has a different extension, okay? So this is the only time that I'm gonna do this manually. Cython is something that will take that file that has exactly the same content and will produce two things. You see, it will produce a C file that you see right there and an HTML. Okay, so here's the magic about this. It doesn't look like well, but basically it turns my Python code directly into C code, where it will be a C extension. And it does with a lot of boilerplate code, but if I do a little bit of searching, you can actually look that it says, okay, so there's this line over here that is fib, remember? It translates that into all this statement. Then after a while, it says, okay, so here's a comparison. A less than 2, it translates a little more into C code. And we don't understand, but this is C. But this is important. Why I say this is important? It's because now I can run my profiler, and without doing any type of difference, okay, I need to. So basically, I forgot about telling you about this, but to import it, my library is called xfib, so I just from xfib import fib. And now, without making any type of difference, it made my code run from 1.48 seconds to 0.47 seconds. So that's just modifying your code and just make it run as C. I made a nice thing here where I could actually get a scale. So I'm gonna get it run. Cool. The other thing that it produces is an HTML file, right? So when you create a Cython, you can actually specify, can you create a HTML file that is literally the same C file that you saw, but in a nicer format with JavaScript and stuff like that. I think that's JavaScript. Okay, so basically it says, okay, remember that line? Here's how I convert it. Remember this comparison? Here's how it goes. So you can now take it and start seeing how your code is. Also, it gives you a visual clue where everything that is yellow is bad because it's C interacting with Python. So what the objective of every C extension is try to make all the yellow go to the first line. That's where you interact with the function, but everything inside your method should be C. Okay, cool. So again, like I say, here this 67, thank you. Latin, sometimes numbers are hard. Okay, 67% faster. Okay, so let me, so Cool. Now, A. This is Fibonacci function. A is not anything. So the main reason why this is actually still slow is because when I want to compare A with 2, I don't know what A is. But I actually know that A is a long. So I will just add that information there into my Cython, and then I will just compile it. And then you will see that now my code is faster. Why my code is faster? I will go here and I reload, and you will see that now this one is no longer yellow. Why is no longer yellow? Because since now Cython know that A is not a random Python object, but it's a long, it can make the comparison right away. So that is actually quite cool. If you see here in the return, there is a lot of code also that is really bad. So the second thing that you can do in Cython is basically you can say, hey, how about you make that function a C and a Python function? And then how about I know the return type of that function? And just a little bit of code, and then I'm gonna run it again. And my code is 97.14 times faster. Let me go again. And the reason why it's faster is because I don't have any Python code inside my function, and only the boundary is the one that it is. Now, this code is artificial because this is literally just something that is bound by CPU. I'm not requesting something on the network. So, do you like this?
Straight.
Awesome. So I'm gonna do one small extra thing, and I'm gonna show you another code that somebody could say, yes, Edith, of course. Okay. So you could do like that one over there. That is the same version of the Fibonacci function, but how you would normally do it in like the second version, loops instead of recursivity. So let me take this one over here and just see how much better than the original code. This is Python, by the way, not Cython. I'm just gonna perfect. And it turns out that just rewriting the function in Python, it was faster. So let's do the same thing. And let me take that same function again, convert it into a Cython file with no extra modification, and just run it. And yeah, so it is faster than the Python version, but not as faster as our optimized version. So I want to show you why that is. Make 2 modifications, and then you're all ready for the day. So again, a lot of yellow. Why is a lot of yellow? Here you see that I'm creating two variables inside my function, but Python doesn't know what types they are. So it has to create, increment, keep tracks of things. But these are clearly just numbers that lives inside that function and doesn't get exposed outside. So I could just modify it, but I'm gonna let Cython do the work for me. So I can say infer. And now if I didn't screw up, yes, I didn't screw up. So Cython in itself, it's gonna go and decide, okay, so X and Y are defined there, and they are 0 and 1. So how about I just see them for what they are, and it says, okay, cool, they are now. So that's, again, like you didn't did a lot of work. Cython did it for you. The next thing that I want to show you that is really cool is here in the for. If I define this as a long, before I do it, do you see that my for is really complicated? Like, that's a for loop. Like, it shouldn't be complicated. So let's compile it. Let's run it. It's faster. And now here's the reason why it's faster. Because now the loop is literally just doing a Python, a C loop. And that is basically it, what you want to do. Just to finish, you just add a little dash of extra hints. And now your code is slightly faster. But again, you went through all this way just to get 0.1%. Now, if you do 42 million times of this request, okay, that's CPU that you say. But that's only a case where you need to have when that happens. So I have more, but it's late and we're all tired. So I'm happy to take questions, but I also like to know, like, what do you think about stuff like this? Did you know that it was possible?
I didn't know it was this easy.
That's great. You wouldn't know this, you wouldn't go into Rust, right? Yeah. Okay, questions?
I guess it's worth mentioning that, so if you have a C library and you want to interface it to Python, you can use Cython to just do the interface part and then call the normal C. So it makes it, although I called what I did cargo call, and I didn't really understand it, it actually wasn't that hard either.
Yeah, so for instance, you can do,
It didn't read the documentation.
so so if you believe me, I have a function that is called right there. So that's defined on a C file. And now you can literally just define and then okay, and this is how you would do, like, there is a file here that is called cfib that has defined as cfib there, and that's how you interface it. Like you say, like, it's really easy. I do this when I did my famous library systemd that interface with systemd. I think that I'm most known for like 2 people besides me. Yeah, go ahead.
So it's just to join in the love affair for Cython. One really cool thing is that a lot of C libraries, they document their API, but what they mean by their API is not literal functions that will ever exist anywhere. I mean, this is a thing you can type into your C code such that it would call this as if it were a function, but often it's actually like a common-defined macro thing. And there's basically no way to do the pound defines unless you are the C compiler. So because Cython runs through the exact same data path as a C compiler, all these libraries work, which is like pretty much every non-trivial C library is using pound defines somewhere. And it's very, very frustrating to try. You can use tools like C types in the standard library.
Yeah.
And try to grab a SO or GY
Yeah.
or you call it. But it's a really an exercise in frustration because like a lot of the nice API for, I guess, performance in C is provided via these macros.
Yeah, and you need to have access to the headers library while you are compiling, not at runtime. Yes, I agree. Yes, Cython is really cool on that sense. Go ahead. Anybody?
All the way back.
Go ahead.
So this is pretty cool. Using Cython, just cover your Python with these little primitive hints. But where do you find the diminishing returns coming into play? Like, this is a nice example for these small little pieces of code. But let's say you take a really big module of Python. Where do you get to this tipping point where you say, you know what, it's just better if you just convert this whole thing in C and then do the necessary bindings to get yourself back into Python?
So I would say the answer to that is profile, and here's my opinion: you should never rewrite all your code, all your Python code into C. You should only rewrite the code that is using a lot of CPU, a lot of memory, and it's actually slow. So there are a lot of tools like profiling, and the first talk showed like a really nice profiler line by line, and you can see, hey, so this function is using time. Let's rewrite this. Let's try to see it. At Instagram, this was a talk on last PyCon, not this one, but last one. In Django, you know, there's like a big function at the beginning that is basically a big if case where you try to match your URLs to stuff. For Django, that was like 40% of our CPU. We wrote that into into Cython. It worked right.
So I saw that you had to like import a decorator for the CP define. Is there a reason why the inference isn't done automatically every single time? I'm guessing there's some ambiguous cases or something.
I would say that try not to. So I would say that the philosophy here is try not to infer stuff out of it, like try not to surprise your developer. But again, I would say like that's design choice of the Cython developers in itself. Oh, sorry. One cool thing I was going to say when you say that about Cython is that Cython is just a transpiler from Python to C. So once you transpile it, you just get rid of your Python file and just send your C code out. So when people are doing pip install, they don't actually need to have your C code. Gentlemen, from the
Also, if you type annotate your Python tree, it doesn't do it yet, but they're going to auto type things better by default once you type in and They haven't, they have parts of it. I don't think it's all there, but the goal is to like some of the things that Alvaro showed you have to do, you shouldn't have to do in the future.
Yes.
So type annotate in Python code, you will get advantages in the future.
Yes. So one thing that is Python is moving really. This is opinion, mine, not anybody else. Python is moving really fast, and the rest of the ecosystem is trying to catch up, and Python eventually will do. Before we do any question of again, we don't need to do it. We can just talk outside. Like again, books are always good. This one over here, it's the best one you can get. It basically goes through all the process of understanding why Python is good, how to use it, and it goes to a really cool example. Usage of this, numerical computation, and when you want to interface with code. So that's it. Thank you very much, guys, for listening to me.